All right, here we go. So 2006 Form B AP Calculus exam question number 6. We're given the differential equation dy dx equals y minus 1 quantity squared times the cosine of pi x. On the axes provided, we're going to sketch the slope field for the given differential equation at the 9 points. The 9 points are the origin, 1, 0, 1, 1, 1, negative 1. 0, 1, 0, negative 1, negative 1, 0, negative 1, 1, and negative 1, negative 1. Those are just the coordinates. For each of these, we're going to take the point, for example, 1, 1, plug in both the x and the y value into our differential equation, and what we're going to get is an expression for the slope, and then we can come back and we can actually draw in our tangent line at that point. We're going to do that 9 times. Part B, there's a horizontal line with equation y equals c that satisfies the differential equation. We're going to find the value of c. Part C, find the particular solution y equals f of x to the given differential equation with the initial condition f of 1 equals 0. Part C is going to take us some time. So let's get going. Part A. We want to generate a slope field, so we're going to take it 1 point at a time. Let's start with the point 0, 0. dy dx at 0, 0 is 0 minus 1 squared times the cosine of pi times 0. 0 minus 1, square that, we get positive 1 times 1 is 1. So I'm going to draw in a tangent line that has a slope of positive 1. Normally when I draw on my tangent lines, I do indicate what the slope is. I just want to make sure I'm not leaving any room for error. Some teachers might encourage you not to do that. What is most important, what the non-negotiable, is that your tangent line must be increasing. And you just draw a short tangent line. Don't go on forever in both directions, because we're saying locally, centered at this point 0, 0, we know that our function will be tangent to that line. Great. Do it again. Find dy dx at 1, 0. Again, 0 minus 1 squared times cosine of pi times 1. That's cosine pi. We get 1 times negative 1, so negative 1. At this point, I'm going to draw in that my slope is negative 1. Great, a decreasing line. Let's find dy dx at 1, 1. At 1, 1, we get 1 minus 1 squared times cosine of pi, cosine of pi, excuse me. 1 minus 1, hey, that one's easy. 0, 0 times cosine pi. Who cares what cosine pi is? Cosine pi is negative 1, but all I know is that because I'm multiplying by 0, my final answer is going to be 0. So over here, a horizontal tangent line. You actually get some easy points out of this. Thank you very much. Over here at the point 0, 1, if x is 0 and y is 1, 1 minus 1 is 0 again. 0 times anything is 0. We're going to get another horizontal tangent line. That's also going to be the case over here at negative 1, 1. Whenever the y value is equal to 1, this expression over here will be equal to 0. Sweet! We've just done 1, 2, 3, 4, 5 points. Well, we have 4 more to go. Let's see if we can pick up the pace. dy dx at negative 1, 1 is, I'm sorry, negative 1, 0. Let's be careful, we're going to pick up the pace. 0 minus 1 squared times cosine of negative pi. We get 1 times negative 1, which is negative 1. We're going to have a decreasing line. If I find dy dx at negative 1, negative 1, negative 1 minus 1 squared is negative 2 squared, that's going to be 4, times cosine of negative pi. Cosine of pi is negative 1. Cosine of negative pi is also negative 1, so we get negative 4. So in order to do this, I want to show that my line is decreasing even faster than it was before. So that's, for me, that slope of -4. dy dx at 0, -1 is going to be -1 minus 1 squared times cosine of 0. -2 squared is 4 times 1 is 4. So now this is going to be increasing. And finally, dy dx at the point 1, -1. -1 minus 1 squared times cosine of pi. That's -2 squared is 4. Cosine of pi is -1, so we get -4. We are decreasing. I hope I did all those right. I know we went kind of fast, but really all we're doing is take your coordinates, your x and your y, plug it into this equation, tell me what dy dx is, and then draw in a little tangent line that has that slope. If I made a mistake, I apologize. But this is generally what your slope function should look like. Okay, now we're on to part D. There's a horizontal line with equation y equals c that satisfies the differential equation. Find the value of c. All right, what do we know? We know that y equals c is a solution. That means I can plug it into my differential equation and we're going to get something that's true. Furthermore, we know that we have a horizontal line. Well, if I have a horizontal line, then my slope is equal to 0. I can use that information over here on the left-hand side. And what that's going to give me is the equation 0 equals c minus 1 squared times the cosine of pi x. And they want me to find the value of c. So let's see, if 0 equals c minus 1 squared times cosine all of the time, well, then c minus 1 squared is equal to 0, or cosine pi x is equal to 0. Here, I can take the square root. C minus 1 is equal to 0. C is equal to 1. Over here, there are definitely values of x that will make cosine of pi x equal to 0. But this has nothing to do with c. This equation is independent of c, and although this has solutions, it doesn't get me any closer to finding c. So our final answer is c equals 1. I think the AP folks awarded 1 point for being able to figure out what c is here. All right, now comes the big mama. C, find the particular solution to the differential equation with the given initial condition f of 1 is equal to 0. So here we go. dy dx equals y minus 1 squared cosine pi x. I'm going to do separation of variables. We're going to multiply both sides by dx. And we get that dy equals y minus 1 squared cosine pi x dx. I'm going to divide both sides by y minus 1 squared. I can see I'm running out of room. dy over y minus 1 squared equals cosine pi x dx. They award you the first point if you properly separate your variables. We're going to integrate both sides. The integral of cosine pi x, well, that's going to have to involve sine of pi x. However, if I do the check, if I take the derivative of sine of pi x, that would give me cosine of pi x times pi. I don't have a times pi here, so it must be because when I do the integration, I have actually 1 over pi sine of pi x plus c. Well, now let's see. The integral of 1 over y minus 1 squared. Many of my students have memorized that the integral of 1 over x squared is negative 1 over x. So let's take as a first pass at this, negative 1 over y minus 1. Does that work? If I were to take the derivative of negative 1 over y minus 1, I would need a chain rule. And I would get positive 1 over y minus 1 squared times the derivative of y minus 1, which is 1. Hey, that works. If I went too fast there, then my recommendation for you would be do integration by substitution. Let u equal y minus 1. And then go from there. What you'll get at the end is the expression negative 1 over y minus 1 plus c equals all this. Now, we're being asked to find the particular solution to that differential equation. We're given that f of 1 is equal to 0. And this is one of those places where I'm just going to decide, once I rewrite this a little bit, that I'm going to use the initial condition now. So let me get a clean sheet of paper, and we can start from here. We have negative 1 over y minus 1 plus c2 equals 1 over pi sine pi x plus c1. Okay, I just wanted to rewrite that. Oh, and we have the initial condition that f of 1 equals 0, which implies we're passing through the point 1, 0. So if x equals 1, back up on that thought. We have constant of integration on both sides. There's definitely no need for that. So I'll make it negative 1 over y minus 1 equals 1 over pi sine pi x plus Charlie. We're going to use the initial condition now. If x equals 1, y is equal to 0. So we'll have negative 1 over 0 minus 1 equals 1 over pi times sine pi plus c. 0 minus 1 is negative 1. Negative 1 divided by negative 1 is 1. Equals 1 over pi times, well, what's sine of pi? The sine of pi is 0. Oh, amen, hallelujah. We get that c is equal to 1. That's not your final answer. That's just the value for your constant. So we can go back to our problem. Negative 1 divided by y minus 1 equals 1 over pi times the sine of pi x plus 1. My goal is to solve it for y. Now we have some choices here. You can get really fancy with your algebra if you'd like to. I kind of like doing that. I'm going to multiply both sides by pi, and I'm going to multiply by y minus 1. My reason for doing that is when I multiply every single term by the pi and the y minus 1, I'm going to get an equation that no longer contains any fractions. And I know from a couple of years in the classroom now that when we can eliminate fractions in an equation, it makes it more likely my students can do this correctly. So y minus 1 times pi, multiply it with this first fraction. The y minus 1's cancel out, and we get negative pi. In the second fraction, pi in the denominator, pi in the numerator, those cancel out. We get y minus 1 times the sine of pi x plus y minus 1 times pi. Okay. Maybe I didn't want to do that. Oh, let's just finish this off. Okay, I want to solve it for y. I see y minus 1 over here. I see y minus 1 over here. We can get negative pi equals, I'm going to factor out the y minus 1. When I factor out the y minus 1, I have sine pi x plus pi. Well, that's not so bad. Solve it for y. I'm going to divide both sides. So we're going to have negative pi over sine pi x plus pi equals y minus 1. So y is equal to negative pi over sine pi x plus pi plus 1. That is my final answer. And if this was a problem where they asked for you to specify the domain, in order to specify the domain, I normally, when I think about domain, I think about domain restrictions. What are the common problems that we would run into? Well, if my denominator was equal to 0, that would cause a problem. If you had a negative underneath a square root sign, that would cause a problem. But let's see. Is sine of pi x plus pi, will that ever equal 0? Well, if sine of pi x plus pi is equal to 0, then the sine of pi x equals negative pi. But what I know is that this expression on the left has to be between -1 and +1. Negative pi, well, that's approximately -3.14159, blah, 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 blah. There is no value of x that is going to make this expression on the left equal negative pi. Since this can't happen, then that means that my denominator can never equal 0. If my denominator can never equal 0, then I actually don't have any domain restrictions. So my domain would finally be all real numbers. You can write it big R, fancy. Or you could say -infinity to infinity. Or you could write all real numbers as your domain. All three of those are equivalent. Well, my friends, that's it. I hope this helps you prepare for the trimester exam or your AP exam. For whatever reason you're watching this, I wish you all the best.